Bow your heads, please.
Heavenly Father, thank you for this day. I thank you for a start to another school year. And
Yes,
I
Lord.
thank you for everyone's protecting, everyone getting here. I just pray if there's anyone sick that you heal them, and I pray that we'll have a great day, and that Mrs. Frady, you'll give her the wisdom to teach us, because she needs all the help she can get.
Amen. Amen. Thank you. Thank you, brother. All right. Let me go through with you what you need to know for this class. First off, I am Katie Frades. Some of you know me, some of you don't. And so I am a disciple of Jesus Christ. I am a homeschool mom of all of my girls. And I am a scientist by degree. My degree is in micro and cell biology, and that means I took every chemistry that was offered undergraduate at Auburn University and the University of Florida, except for P-Chem. That's the only difference between me and a chemistry major. I didn't have to take P-Chem, and so, which is physical chemistry. And so I have a lot of chemistry background. I never felt like I understood chemistry like I do now. And so I personally think that's why I can do a good job with the Lord's help, teaching you chemistry, because I know what it is to not understand it. Jay Wiles is brilliant. He's the guy that wrote this book. He has a PhD in chemistry, so he assumes you can see what he sees. If you can't, I do not want you to worry about it, because I'm going to teach you my way when you get to class. So you just do what you're supposed to do, which is read the stuff. Try to do the math. Okay? You are always supposed to be looking at the answers after every problem that you do. I don't want you to do 2 problems in a row without checking the answer. Now, he says on the study guide he doesn't want you to look at the answers till you're all the way done, and I'm telling you, no. Practice does not make perfect. Perfect practice makes perfect. I want you to do a problem and check the answer. Do a problem and check the answer, because I don't want you going through and doing a bunch of problems wrong and then figuring it out after you've patterned that in your brain that that's how to do it. Does that make sense to everybody? Okay, so we will cover we will cover 1 chapter every 2 weeks. We will alter that slightly because the acid-base chapter is a little more intense, and therefore we will spend 3 weeks on that, and we will shorten something else that's easier. Okay? Which I did in biology too. And you guys trust me that had biology. So trust me, I'm trying to do this for your sake, okay? But in general, what you're gonna do is you did the first half of this chapter. We're gonna go over today. We're gonna do the labs the best we can. Always make sure you read the labs. When it says to prep for a lab, you're supposed to do the labs in 4 parts. Those of you that had me before have done this already. Your purpose, procedure, but the observations now becomes observations and calculations, because this is where you'll do the math portions. With the things that you observe, that you've written down, you'll do the math portions in there. And then your conclusion. He will usually discuss approximately what you should put in your conclusion after the experiment in the textbook, so you can get an idea. He says you should be writing down why you did the experiment and what you learned. And I don't want any answers like, 'cause they made me. Okay? So let's try to, I know, Andrew would go there. So let's try to come up with what did we learn, and how did that tie together with our observations, or how did that not tie together with our observations? Ours went belly up, but we were supposed to be learning, okay? And that's honest, and that's what I want you to do. Make sure that you do the lab write-ups, because this is a high school science with lab credit, and therefore you need the lab write-ups, because there are a lot of colleges that will say, prove to me that you had this high school science with lab. And if you produce your notebook that has your tests in it, that has your homework, and has your lab write-ups in it, you'll be okay. I've had that happen to students, and you will be okay. Most schools. And hopefully everybody printed out your syllabus. It's right there in your syllabus how to do the lab write-up. And we'll go through them as we'll go through and do the calculations together. I'm going to tell you that right now. I'm not going to leave you out there in the wind on the calculations, okay? So we'll go through the calculations together, but there are sample calculations at the back of the chapter. And so after you do your comprehension check questions, you can check those in the back of the chapter. The answers are there. And then when you do your review problems at the very end when you're getting ready for the test, so that'll be the 2nd week, you'll do the review problems. That one you would have to use the test book with the answers in it. And that'll have the answers to the study guide, the review problems. And then just don't look at the test till you're taking it, okay? That'd be cheating. And then after our class, the second class where we finish and we'll go through all the review problems and hopefully get you all squared away, then you will go home, and I'm hoping you will take the test like the next day if it's at all possible. Go ahead and study and take that test the next day while it's fresh in your mind. And then that gives you the rest of the week to get ready for the next class. We will grade your test together the first thing after prayer, the following class. So the third class, after we pray, we're going to grade the test together. If you're like me, you won't be able to stand it. You'll have to have the test graded before then because you'll have to know how you did. And I understand if you're like that. Feel free to do that, but I still want you to bring your test the next class because we will be going over them together, and you might be able to get partial credit. And in this class, there is a lot of partial credit because we will have very long problems that are worth lots and lots of points. And so I want to be able to give you partial credit wherever I am. With that thought in mind, you must write down everything. You must write down everything that you do so that when something messes up and you don't have the right answer, I can look at what you did and go, oh, you're right up to here, so I can give you 15 of the 20 points. Do you see what I'm saying? I mean, I have people do everything right and their calculator, they punch something wrong in their calculator. So with that in mind, do all your calculations at least twice. Get the same answer twice before you figure it's okay. All right? That's how your parents used to do checkbooks, you know? They would do it twice, trust me. So anyway, so watch that. We already went over, everybody's got a calculator that they're happy with, that they can do exponents on. Very important that you can, raise it to whatever exponent, because you'll be doing positive exponents and negative exponents. You are going to have to, don't think you're going to be able to play that game where, just to manipulate it. No. You have to be able to do it and do it quickly. Okay, so, okay, let's see. Is there anything else? Oh, anytime you get to vocabulary words, those of you that know me know this. Those of you that don't, I want to tell you, anytime you get to vocabulary words, I would really rather you define things in your own words whenever possible, as short as possible. Okay? My old students have heard me say this before. If you're going to memorize something, memorize scripture. Don't waste your brain on these other things. There is a lot to memorize in chemistry. And I'm going to tell you this right now. So you don't want to waste your time memorizing somebody's words, except for God's word, okay? So what you're going to memorize are the concepts that you need. And it's best to put them in your words as short as possible so that you can memorize those concepts. I will tell you, and those of you that have biology with me know, I never asked you to memorize anything you didn't absolutely have to. There will be things in this class that I will say to you, memorize it. And when I tell you that, I'm not trying to be Yoda. Memorize it, okay? Because that means you're going to need it. And you can't go on without memorizing it. And I think that's what makes chemistry hard for a lot of people, is they don't realize if you will memorize what you're supposed to, I'll get you through. The Lord will get you through, and I, with the Lord's help, will get you through this. But you do have to memorize the things I ask you to, and then make sure that you're doing your problems, and do them, and practice them, and write down what you're doing. I'm going to have to use my glasses. Last year, thank you very much. Last year, I fought back and forth with putting them on and taking them off. I'm past it. I can't see. So, okay, first thing, we're learning about chemistry, which is the study of matter. And so that's our first definition, is what matter is. Matter is anything that has mass and takes up space. Oh, yes, I'm on the first page. If you're not there yet, go ahead and open your book. It'd be good to follow along. You definitely want to have some paper. You want to have your calculator nearby in most cases. And something to write with would be ever so helpful. Are we there yet? Matter is anything that has mass and takes up space. That is probably as short as you're going to get matter, I'll be honest with you. Anything that has mass and takes up space. That's pretty concise if you think about it. So the first way that we need to look at matter is through measurements, because when we measure matter, then we're able to determine different things about matter. So first he starts you off very gently. He uses the inches, and we've got rulers that have the metric system right on them. We will be using the metric system. I know that we in America use the English system, which are inches and feet and yards and miles. The metric system uses the meter as your basic unit. When we measure, this is your basic unit, which is a meter. So I want you to notice, here's a yard. It ends right here, okay? And this stick is a meter. So you can see how close a meter is to a yard, can't you? I don't think in metric. I have been an American on the English system. I convert. It's the same reason I don't do well with foreign languages, because I took 2 years of French and 1 year of German, and I'm constantly translating in my head. I can't just think in the language, and I have trouble thinking in the metric system. Now I can think a liter, because we get 1 liter bottles of water all the time, so I'm good with a liter. No problem at all. 2 liter bottle, I got it. You know, it's because I use it all the time, but I don't use meters very much. So, but the metric system is what scientists use all over the world, so that is the only thing we will use. Now, I appreciate that he uses the inches here, but I think we can kind of get past that. He tells you on page 2, well, the other thing is this. He mentions that when you measure things that you should start at the 1 and measure it, and you feel free to do that. I'm going to tell you why I refuse to do that. I always forget to subtract the 1. You too, Luch? Same thing? I'm there, man. I am so there. And I don't need anything else to mess me up. I got enough just keeping up. Okay? So as far as I'm concerned, these rulers have a mark that's inside the edge of the ruler. If the one I just gave you doesn't, the other ones do. The ones in your boxes should. The mark is inside. You would start at that mark. Okay? I would suggest that. And did you have a question, Jay?
No, I was saying that in the book he said his reason was the end of the ruler can get
and these rulers, right, these rulers actually have an edge, you know, and it's marked. Okay, so I would suggest you do that. I'm glad I'm not the only one that forgot to subtract. Excuse me, misery loves company. So, all right. Okay, so with that in mind, he tells us about the units. And the units that we have to know, your base metric units, like I said, if you're measuring something, this is a meter. Okay, so that's your base metric unit on distance. What is your, do you guys remember from physical science, what is your, because you didn't read it yet, what is your base metric unit for volume?
Oh, like liters or
Liter,
gallons?
absolutely, it's liters, and in the English system it would be gallons, but in the metric it's liters. Actually, you did read a little about that, because we're going to be measuring, we're going to be measuring centimeters, centiliters today, and so we're going to use our graduated cylinders for that. Okay, good. So liter, that's your base unit, okay? And then for mass, the base unit is a gram. And a gram is what a dollar bill weighs. On page 2, it talks about what a unit is, which is just the quantity we use to do measurements. Hopefully you all remember that a number without a unit behind it is an incorrect answer. So whenever you write a digit, there should be some unit behind it. It should tell me if you're talking about inches or yards or whatever you're dealing with. Make sure that it's there, otherwise the answer is incorrect. Then he talked to us. Let's see, so that's on the bottom of page 3. And there's the first comprehension question there, and it says, which is longer, an object with 1 inch, that's 1 inch long, or one that is 1 centimeter long?
1 inch.
1 inch. And all you really have to do is just look at the ruler that's in front of you. Here's an inch, and a centimeter is this little bitty guy here, right? But it tells you right above that in the text that a pencil is both 7.41 inches and 18.82 centimeters. So from that, you know that if that's true of the pencil, that the inches have to be longer than the centimeters, correct? So you didn't have to look at the ruler. At the bottom of the page, it tells us that the unit of measurement is just as important as the number. You must always list that. I just mentioned it. Then over on page 4, we go to significant figures. And significant figures, significant figures are really very important. And it defines for us there on the page that a significant figure is a digit in a measurement that contributes to the measurement's precision. Now, that's what's so important about it. When I was in college, I was sure that they were just torturing us with significant figures, because you got counted off if you didn't have the right number of significant figures, which you will be too. And so I was just sure it was just a way to torture students, okay? Because I don't think I was ever taught exactly what it was like he does, and he does such a beautiful job. God bless Jay Wiles, I mean this. Significant figures actually tell us something. They tell us the precision of the instrument that was used. So now we have to say, well, what is precision? There's 2 words, accuracy, which is about how good a job we do, if you measured it correctly or not. That's accuracy. But precision is the instrument. Precision tells you if the instrument was marked off to the centimeters or millimeters or even smaller. Okay? So precision literally tells us something about the device that you used to measure something. Let's say we did something depressing and stood on a bathroom scale. Okay. And we and we saw what we weighed in pounds. All right. But let's say that we were going to do Weight Watchers, and so we had to measure our piece of meat that we were going to eat, our hamburger. You wouldn't want to put it on the bathroom scale to measure it, would you? No, the precision wouldn't be nearly accurate, precise enough to give you an accurate reading, would it? Because if you wanted to measure if it's, 3 grams or 4 grams or 3 ounces or 4 ounces, I guess 3 grams or 4 grams, that'd be a really small burger. Okay, so let's say 3 ounces or 4 ounces of burger, it wouldn't even show on your bathroom scale, would it? No, you need like one of our scales, like what we have here, to be able to measure something small like that, correct? That's because the precision on this instrument is much greater than the precision on the bathroom scale. If you were measuring this room, you would probably want, and if you did it, let's say in the metric system, you would probably want to use a meter stick to do it. You would not use your car odometer, would you? No, wouldn't work very well, right? Why? Well, because the precision on your car odometer is really to measure miles, and it'll give you tenths of a mile, but that's about as close as you're going to come, right? So you wouldn't want to use that to measure this. And then he did mention that if you were measuring, he said the pencil, you would use centimeters, and then he went on to say, but if you wanted to measure a grain of rice, which is very small, then you would probably measure it in millimeters. And so and it was within your reading, so I'm going to do it real quickly. That's why with the metric system, we have the prefixes that we attach so that we can use those different things. And that was over on page 12. We're going to come back. I know we're supposed to be on 4.
Significant figure. Is there a shorter definition that we can?
Oh, no. Significant figures you have to be able to use. I'm not so worried about you defining it as using it. So let's look at significant figures. So let me show you. Everybody's got a ruler right now.
Yes.
And everybody's got a pen or a pencil or something, a pill bottle, something you can measure, right? And make sure you do it in centimeters. Okay. Look at the graduation on here. You see that the centimeters are marked off to the 1, 2, 3, 4, and the thing is, what, almost 30 centimeters long? But then there's 10 marks in between each centimeter, aren't there? Which means actually on this, the millimeters are marked off. But let's say we're measuring our pencil or our pen in centimeters, then what you're going to do is your pencil or pen is probably different length than his, so go ahead and measure yours. And let's say, here, I'm going to measure my little tiny graduated cylinder. How's that? And I'm going to have to put glasses on to actually see. Do you not have? Yeah, you've got one. Okay. Now, what you want to do, put it at the edge, put it all the way over. My little graduated cylinder comes to over 18. So the first thing I'm going to write is the 18 centimeters. So I'm going to put the 18. Yours is going to be smaller because you're using something smaller than I am. But I'm not done yet. Because when I look at this, it goes to 18, but it goes a little bit past it.
Those little notches are millimeters, right?
Those little, but just think of it as a tenth of a centimeter at this point, right? So you're going to go point, and mine goes before the first line. So this would be a 0, because I didn't get to the first line. But that is the exact precision of the instrument. So I have to estimate 1 past that. So in my case, I'm going to estimate it as a 0. Okay? The proper number of significant figures is the last digit is estimated past the precision of your instrument. You will always estimate the last digit. That's what he tried to explain in there when he was going through all that. Okay? So, yes, David?
So if mine's 18 and 2/10, I would add a 0 behind it too?
Right. So if his is 18 and 2/10, and it looks like it's dead on to you, you would put a 0, because this shows scientists all over the world, if they see your data, they know that the precision of your instrument was to there, that it was actually marked off to there, and that you estimated that last digit.
The zero is like a period.
The zero is actually telling a scientist where the precision ended and you estimated one past that. Isn't that neat? That's the part that I never understood in school. Nobody ever explained that to me, that the significant figure wasn't there just to torture us. That there actually was a meaning to it. That it actually tells you something about the instrument that was used. Okay? With that said, there are rules to be able to determine the significant figures in a number. And that is on page 4. And it tells us, and I like these rules, they're very concise. It tells us that any digit that's a non-zero digit in a number is a significant figure. So the only problem you're going to have with significant figures are the zeros. Okay? That's where things can get dicey. Let's look at how you figure out significant figures. It gives us the example problems, but let's go ahead and go to the check your comprehension. The two rules on zeros is, if a zero is between two significant figures, it is a significant figure. That one's easy. The last one's where people get messed up. If a zero is to the right of the decimal at the end of the number, it's a significant figure. Now, let's go back to our 18.00, and that was centimeters. Do these have any numeric value?
No. Yes.
Not numeric value. Any zeros to the right of the decimal have no mathematical value as far as numeric value, correct? It's just zeros. It's nothing. I could rewrite that as 18, couldn't I? But it does have value as significant figures because this tells me that my precision of my instrument was to here because we know that one was estimated. It's telling me something. So in chemistry, it has a value. And therefore, the zero to the right of the decimal at the end of the number is significant because it's telling me something. Does that make sense? And this zero is between two significant figures. So it's a significant figure. Do you see how to work that? So this number on the comprehension check, number 2A, we have 0.01020 inches. Now, is that zero significant? No. This zero, is that significant? Yes, because it's between two significant figures. Let's look at this zero. To the right of the decimal at the end of the number. Fits both criteria. So far, these are significant. What about this zero? That zero is not between two significant figures. And it is to the right at the decimal, but it's got to be to the right of the decimal at the end of the number. It has to be both. Is it both? No. So it is not significant.
But if you didn't have that zero, then the 1 would be a tenth, and the 1 needs to be in 100.
No, now you're talking about mathematical placeholders. And so you learned about scientific notation. Because scientific notation says that, and I know I'm skipping around, but you guys all read this, right? Scientific notation is where you have one non-zero digit to the left of the decimal. That's all, and everything else is to the right of the decimal, right? So to make this in scientific notation, we would go 1, 2. So we would go 1.020 times 10 to the negative 2. Now, I've just written that in 4 significant figures, haven't I? Because this has 4 significant figures. Scientific notation is, oh, our friend, okay? Because with scientific notation, as soon as you look at it, it tells you the number of significant figures. You don't have to figure it out. It's there. It's right there. Hello, I'm here. You know? So scientific notation's great. But, David, that's why that's not a significant figure. Because I can rewrite this way and it means the exact same thing. I don't need that zero. Does that make sense? That was a good question. Yes?
For rule number 2,
yes.
Does the zero have to be directly between them?
No, absolutely not. Let's see. Let's say, oh, here we go. The next one. We'll use that. That was very timely. Okay. These zeros are between two significant figures. It could be That's significant. This 0 is to the right of the decimal at the end of the number, which makes all of those significant because they're between two significant figures. Okay? So I guess I would have just rearranged those rules and make rule 2 rule 3 and rule 3 rule 2. Because if you go through, all non-zero digits are significant. Any 0 to the right of the decimal at the end of the number is significant, and any zeros in between significant figures are significant. So very good question. Yes, Andrew?
This might be a little, but couldn't you just put infinite amount of zeros behind a decimal point and just say that all those zeros are significant and have this huge...
That is the case on conversion factors, and he told you that. So when you say that there's 100 centimeters in a meter, that has an infinite number of significant figures, and therefore you do not take it into account. When you're calculating with it, all you take into account is the original measured number, and that will determine your significant figures because of the infinite number of significant figures on calculations, because they're so precise. So that does come up. Not a stupid question. I'm sorry, Andrew, I don't think there are probably going to be any stupid questions in chemistry because it's kind of one of those that make you blink and twitch, you know, so you guys feel free to ask whatever comes up. Yes?
So if I had a number like 0.0007, those 3 zeros in the middle would not be significant?
Oh, no, they are.
Or they are?
You said 0. Say it again?
0007.
Oh, no, then you're right. This is our only significant figure.
But if I had 1.0007?
Then all of it is significant. Absolutely. Did you hear what you just said? So if we take away this 1, how would I write this in scientific notation?
7 times 10 to the negative 4.
Good, because you go 1, 2, 3, 4.
That's how many significant numbers you have?
No, I've only got one significant figure, so that's 7 times 10 to the negative 4th. And see how scientific notation, it just tells you right there how many significant figures are there. You're done. Yes?
Yeah, but isn't it true that if I have 1.0007, those 3 zeros are not being measured, like they don't, or are they?
Oh, no, now those are all significant. And so, yes. So now you have 1, 2, 3, 4, 5, 6 significant figures. And this is going to come into play when you start doing your calculations. Because when you add or subtract significant figures, and you already read about this, but we're going to come back to it. When you add and subtract significant figures, then you actually have to take the least precise, and your answer can only be as precise as the least precise of the 2 digits. When you multiply and divide, you actually count the number of significant figures. Whichever one has the least number of significant figures, your answer has to be in this. So let's say you actually had to multiply these 2 numbers together. Then whatever your answer was on the calculator, you'd have to give it in one significant figure. And let's say your answer was, and it's not in this case, but let's say your answer was 1,000. But you have to give 1,000 in one significant figure. How would you do that? How would you do it? Scientific notation. There's your 1,000 in one significant figure.
But how would you do it if your answer was just randomly stating like your significant figure, your lowest one was, you only had 2 significant figures, but you got an answer with 3 significant figures?
Then you just round it. Very good question. Very good question. He says if you put in your calculator and it gives you 3 significant figures in your answer, but you have to answer in 2 because you only had 2 significant figures in one of the things that you were using and you were multiplying or dividing, you would round it to 2 figures. So you would, and remember you round from 0 to 4 rounds down, and from 5 to 9 rounds up. And that's very important because I've had students that were really, really good at the whole thing and always would forget to look at the digit right behind the last one, so he'd always forget to round up when he was supposed to. So make sure that you look at that digit before you do your rounding. Yes?
You said the rules were different for adding and subtracting.
Yes, and so let's do that. Let's go there. Is everybody okay with just counting the significant figures now? Okay. All right, then let's move on. Number 6, page 6, I'm sorry. It's talking about using them in problems. And in the pink box, And I'm going to tell you right now, if for any reason we don't get to the labs today, we will be doing them next week. Okay, we're going to try today, but I won't hold you into lunch. I'm not that cruel. Okay, I'll save cruelty for other things. Anyway, on page 6, it says, when adding and subtracting measurements, you must report your answer to the same precision as the least precise number in the problem. Now, Maggie, that is probably the hardest thing you're going to learn all year. I'm going to tell you that right now. That is probably one of the most confusing things that people ever have to do with these, is the adding or subtracting. And do you know what? It's like fractions. When you add or subtract fractions, because you got to get common denominators and and it's so much harder. Multiplying and dividing fractions, ooh, yeah, party, no problem, right? No problem at all. This is the same way. It's the same way. When you're multiplying and dividing, you just count them, give your answer in the least number, you're done. No problem. Da, 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 da. But when you add or subtract, here we go. So when you add or subtract, he shows you there the example problem. And if you did this in your calculator, you would get the answer that he's got there. 102 centimeters. Oh, I can't do that. I got to do this. Okay, 102. So we got 102 centimeters. And I'm just going to show you. I know you can do this already in your head, but 3 centimeters. And so when you do this in your calculator, you're going to get 86.577 centimeters. Okay, but you can't answer in that. You have to look at the precision. The precision to this one is to the ones place. The precision of this one is to the thousandths place. 1/1000th place, correct? So the answer has to be the least precise. That means it can only go to the ones place.
87.
So the answer would be 87 centimeters. Okay? Everybody sees how that works. Let's try, let's not go right to the other way, which is easy. Let's try another hard one. So let's do, on page 8, comprehension check. It says, what is the correct answer when 3.1 inches is added to 8.991 inches? Okay, what you get out of the calculator is 12.091 inches. But that answer would not be correct because it's got way too many significant figures, doesn't it? So which place does the least precise go to? Tenths place, right here. This is the tenths place. This one, once again, goes to the 1/1000th place, so we can't use that. So this answer has to go to here. So how am I going to answer it? Good. I'm going to go 12.1 inches, and that would be the correct answer. That's why you have to look at the digit past it to see whether you're rolling up or rolling down. It will be wrong otherwise. Okay? All right. And so once again, that's the hard part, believe it or not. The easier part, turn back a page.